So we've looked at right angle triangles and the checklist that we run through to identify whether we use Pythagoras or trigonometry. But what do you do if you find yourself in the situation where there is no right angle triangle? In some cases, you'll have an isosceles triangle, which can be split in half to two right angles. But towards the back end of a calculator paper, you're highly likely to see triangles that look like this. They're not isosceles. You can't split them to make right angles, and you're going to need to negotiate what you have in front of you without the use of Pythagoras or SOHCAHTOA. Now, if you do get any kind of a question that involves a triangle that doesn't have a right angle, then there's an entire section of the formula booklet dedicated to this type of question. And that's down here. And it says, in any triangle of A, B, C. And just a little note about how they've set this out, because as it was with a quadratic equation, they've actually been really helpful to you here. The capital letters always represent the corners, or the vertices of the triangle. Now you'll notice that the corner, capital B, is the angle, right? The angle would be capital B. Directly opposite that is a lowercase b. So the side opposite the angle is the lowercase of whatever the angle is. So that's angle A, that's length lowercase a. Angle C, length of lowercase c. And that's helpful because if you look at the formulas, then they all reference sine or cos of the capital letters, but the lengths are all in lowercase. Now, people get themselves into an awful mess when they're looking at this section of the formula page, because they look at their question and they desperately try and say, oh, well, which one is A, which one's B, which one is C? And then they try and plug the numbers into here. But if you notice, with the sine rule, it doesn't matter which is A, which is B, which is C, because they're all equal to each other. And for the cosine rule, whatever angle you have, so in this case, cos of A, you would use that to find the length its opposite. So you can see that A squared is equal to that squared plus that squared times by two lots of that times the cos of A. If we were looking for B squared, it would simply equal the other two sides squared and added together, take away 2 times the product of the other two sides, multiplied by cos of B. Hopefully that'll become a little more clear when we're looking at it, and we'll have a look at area at the end. So let's have a look. What do we have here? On the first triangle, I've got no right angles, but I've got 2 sides in use, and I've got 2 angles in use. Now, it doesn't matter whether I'm trying to find a side or an angle. Just like Pythag and Trig, all I need to know is what am I using? 2 sides, 2 angles. And also, if I look, the sides and angles I'm using are opposite each other. The angle of X is opposite the length, 7 centimetres. The angle of 25 is opposite the length of 10 centimetres. So whenever you have 2 angles and 2 sides, you can use the sine rule. And don't get bogged down, like I said earlier, in what's A, what's B, what's C. I'm not even going to label these up as A, B and C. I'm just going to take the rule as it is. And it says that the length of A, when divided by the sine of angle A, is equal to the length of another side divided by the sine of its opposite angle. So I'm going to start with 7 and with X. And so I'm going to say X, or sine of X over 7 is equal to, and I'm going to make sure I get it the right way around, the angle first, because I did the angle first here. It wouldn't matter if it was that way around, but I like to put the unknown on the top because it's easier to rearrange. So sine of X over 7 is equal to the sine of 25 over its opposite length, which is 10. Now I've done this, hopefully you can see that in order to get sine of X on its own, I'd have to multiply that 7 away. So sine of X is equal to 7 lots of sine 25 over 10. Now at this point, I'm going to work this out. Sine of x equals, so I'm going to put in my calculator 7, open bracket, quotient, sine of 25, close this 25 bracket off, over 10, and that equals 0.295, blah, blah, blah. I'm keeping that on the display. That stays on the display. I'm just going to make a little note of it here. 0.2958, dot, dot, dot. I put the dot, dot, dot to show I'm not cutting my number off. So that's all well and good for sine of x, but just like when we were looking at trig, I don't want sine of x, I want x on its own, so I need to shift sine. That will leave me with x equals sine to the minus 1 of 0.2958, dot, dot, dot. So remember, I've still got that full answer on my display. I'm just going to press now, shift, sine, answer, close bracket, equals 17.2. So x equals 17.2074, and that goes on. And a question would ask you to a particular degree of accuracy, but I'm not going to do that here because I just made that up. So what is x equal to? 17.2074 degrees, because it was an angle. Alright, so that's the sine rule. 2 angles, 2 lengths. Let's have a look at this one then. So here, I've got a non-right angle triangle, 2 lengths given, an angle given, and a third length. Okay, so I've got 3 lengths in use and an angle in use. More often than not, it is going to be a length that they'll ask you for, but if it's a particularly tricky question, they might ask you to find the angle. However, you will of course get a mark for spotting 2 lengths, a third length, and an angle. That's going to be this one. 3 lengths are in use and 1 angle. So that's the cosine rule. So I'm going to start by writing out what my cosine rule is. And no one's expecting you to remember the cosine rule. Next year they will have to memorize it. So the cosine rule starts off like Pythagoras. And when we had a right angle triangle and all 3 sides were in use, it was Pythagoras we used. So that makes sense. So a squared equals b squared plus c squared. That should look familiar. And then comes the cosine bit. Minus 2bc cos a. So that's just what it says in the formula book. Notice, I've not put labels on any of my corners. I'm not going to label this up, because I know if I'm finding the length of a, which in my case is x, then the only other thing I need to know is that I'm using the angle directly opposite it at the end. So let's write it out with regards to my question above. X squared is equal to, I don't know which is b, I don't know which is c out of 5 and 7, and it doesn't matter. I just know it's the 2 lengths squared and added together. So I'll do 5 squared plus 7 squared, and that's minus 2 lots, and again I'm substituting a value for b in, and I picked this as my b, and that was my c, and that gets multiplied by cos of a, which is 37. So I've ended up with x squared equals 5 squared plus 7 squared minus 257 cos 37. And then I can go ahead and put that all into my calculator. So 5 squared plus 7 squared minus 2, open bracket 5, open bracket 7, cos 37, close that bracket off, equals 18.095. So x squared equals 18.095 dot dot dot. I'm going to keep that on my display because I don't want x squared, I just want x. So x is equal to the root of the answer you just wrote down. And to do that on your calculator, you just press root answer equals, and that gives me 4.2538. So x equals 4.2538 ... and they'll give you a degree of accuracy, which I haven't done here, but it's a length we found, so that's centimeters. So sine rule, 2 angles, 2 lengths, opposite to each other. Cosine rule, 3 sides, 1 angle. All right, let's have a look at this question. I can see that this is a triangle. It doesn't have a right angle. However, it has got these marks on these lengths, and that means that they're both the same. So this is an isosceles triangle. I could cut it down there and know that that would be a 70-degree angle, and this would be, I don't know, because I haven't got enough information for that. So whilst you may be tempted to cut it in half, it's not possible here. We have to use either sine or cosine. So let's look at what the question wants, because they haven't put everything on here. They want us to calculate the length of PR. There's P, there's R. So this is what I'm missing. Give your answer to 3 significant figures. All right, well, they've told me that that is the same length as that, so I know that's 8 centimeters. So I've got a side and another side, and I have to find the third side, but there's also an angle in use. So 3 sides in use and the angle. That means I need cosine. So I need to use the cosine rule. And the cosine rule states that a squared equals b squared plus c squared, just like Pythagoras. Then you take away 2bc cos a. Now again, it doesn't matter what's a, b and c just as well, because these are labelled p, q and r. But what does matter is that I'm looking to find the length directly opposite the angle that I know. So instead of a squared, I'm going to say I want x squared. And I know it's equal to the other 2 sides squared. It doesn't matter which order. But in this case anyway, they're 8 and 8. So 8 squared plus 8 squared minus 2 times one of the sides and then the other side. And that's the cos of the angle opposite the length I'm finding, so 140. So what I need to do then is put that into my calculator. So turn it on. 8 squared plus 8 squared minus 2 open bracket 8 close bracket open bracket 8 close bracket cos of 140 close the bracket off equals 226 point blah blah blah. So I'm going to write that down, and remember that is x squared equals 226.0536 ... But I don't want x squared, I want x, so I need to find the root of that in order to get rid of the square there. So x equals, now my long answer is still on my calculator display. I'm just going to press root answer, so it looks like that, equals 15.0350 ... How accurate did they want it? 3 significant figures. 1, 2, 3. Cut off there. The 3 doesn't have an effect. So x is 15.0 centimeters. Do I need the 0.0? Maybe not. But they wanted 3 significant figures, so I'm giving them 3 figures. Right, here we have another triangle. Not right angled, so I can't use my right angle triangle checklist. And it says your diagram not accurately drawn. That means you can't measure anything, so don't get a protractor out thinking you can measure the angles. So they want us to calculate the length of LN. I'm going to mark that on because that's the side I'm trying to find. And they want the answer correct to 3 significant figures. Now, earlier on, I said that we would use the sine rule if we had 2 sides and 2 angles. That looks like it's what we're going to use here, but let's not commit just yet. The cosine rule then says, given 2 lengths or using 3 lengths plus an angle. And if you look, there's 2 lengths there and an angle. So actually, cosine looks like it might be a little bit more appealing. However, remember that in order to use the cosine rule, we need whatever length we're trying to find or whichever angle we're trying to find, we need to have both values for them, or we need to use both values. So if I'm looking to find that length, in order to use the cosine rule, I'm going to need to have that angle, which I don't actually have. So that's a problem. Now, eventually, if I can find that angle, then there's nothing stopping me using cosine rule to find this length. But as it stands, I can't use that. What I do need on there is more information about this triangle. So I know I have that angle and its opposite side. So they go together. That might be useful for me. I've also got this side. Now, from this side, I could find out what this angle is here. And I'm going to just call this angle L because it's got an L there. So let's find out what that angle is, because the more information I can get at this point, the better. Now, 2 sides, 2 angles. I should know that that is going to be using the sine rule. So let's look at the sine rule. And the sine rule tells me that if I divide the angle by the side or the side by the angle, the ratio is the same for all angles and all sides of this triangle. So as it's that I'm trying to find, I'm going to say that sine of L over its opposite side, which is 12.8, is equal to the sine of 136 over its opposite side, which is 15.7. So I've now got that little equation set up. I know I want sine of L on its own, so I need to multiply by 12.8. So sine of L equals 12.8 sine 136 over 15.7. You may wish to do that on a calculator like I did before and then do shift sine, or you may be good enough with a calculator to realise you can just double up on the brackets, and that's what I'm going to do here. So I'm going to shift sine straight away, leaving me with angle L equals sine to the minus 1 of this. So 12.8 open bracket sine 136 over 15.7, close the bracket, close the bracket. And when I put that in my calculator, that's going to end up telling me that angle L is equal to 34.495 ... So calculate it so you get to that point. Alright, now I'm going to just make a note of this on the diagram, and I'm not pressing clear on my calculator display. I'm keeping that on there. That's what it looks like. I'm keeping it on there. So I'm going to make a note here that this is 34.495 ... Now from that, I'm going to be able to find what this angle is. Because this is a triangle, and it doesn't matter how complicated the trig or algebra or anything gets, the angles inside a triangle are always going to sum to 180 degrees. So in order to find this angle, which I'm going to call angle M, capital M, angle M equals the 180 degrees in a full triangle, take away the 136 degrees that I have there, take away the angle I just found, which is 34.495 ... The reason I'm keeping it like that, you'll see in a minute. So angle M equals, so there's my last answer. I told you I was keeping that in there. I'm going to not press all clear. I'm just literally going to start typing 180. Take away the 136. Take away my answer equals 9.504. So m equals 9.5042. It's not the end of the world if you have rounded that off and you're using it throughout. You will get follow-through marks if you've rounded it incorrectly, but I'm just going to try and keep it as accurate as possible. So I know now that that angle is 9.5 degrees. So that's this one here. 9.5 degrees. Now, because I know that angle and I know the two lengths either side, I could easily find that using the cosine rule. But I could also note that because they're opposite, and I have two other lots of opposite angles, then I could just use the sine rule. So I can use either here. I'm going to go ahead and do both ways just so you can see it. And I'll use a post-it to break this up. So if I was answering this from this point onwards using the sine rule, what I would do is to find x, I'd know that x over the sine of 9.5 is equal to any of the other lengths. I'm going to go with the one that was printed on the paper. 15.7 divided by the sine of its opposite angle, so sine 136. I want x on its own, so I need to multiply that sine 9.5 away, which will leave me with x equals sine 9.5 times by 15.7 over sine 136. And when you put that into your calculator, you will end up with x equals, let's do it, sine of 9.5, close the 9.5 bracket off, open a new one, press the quotient key, 15.7 over sine 136, close the 136 bracket off, press across to come out and close the main bracket off, equals 3.7324, 3.7302 ... What degree of accuracy did they want in the question? 3 significant figures. So 1, 2, 3, cut it off there. The 0 doesn't have an effect. So x equals 3.73, and it's a length. So that's centimeters. So that's how you could finish that question off using the sine rule. And that's probably the one I would have gone for in this question. However, there is nothing stopping you using the cosine rule to finish the question off. So, using the cosine rule, and remember the reason we're allowed to do this now is because we found this angle and I need to find the opposite length, but I have been given the lengths that sandwich the angle each side. So I'm going to start by copying out what the cosine rule is on the paper, even though I don't find it particularly helpful. A squared equals b squared plus c squared, like Pythagoras, minus 2bc cos a. Again, I don't care what a is, what b is, what c is. All that matters is I need to find the length opposite an angle that I have. So instead of a squared, I've called it x. So x squared equals these two lengths in any order. I'm going to call that b and that c. So 15.7 squared plus 12.8 squared minus 2 15.7 12.8 cos 9.5. I'm going to put that into my calculator. So 15.7 squared plus 12.8 squared minus 2 open bracket 15.7 12.8 cos 9.5 close the cos bracket off equals 13.922. So x squared equals 13.922, and that number continues. I'm not deleting it because I don't want x squared. I want to know what x is, so I need to root that answer to get rid of the squared. So I'm going to press root answer equals 3.731, 3.731, and that goes on, and I wanted it to 3 significant figures. Yep. So that is 1, 2, 3, cut off after the 3, the 1 has no effect. So x equals 3.73 centimeters, and hopefully, yeah, you can see it matches up with the answer I got for the sine rule. So you could use either their sine or cosine. Right, we're now going to look at using trigonometry to find the area of a triangle. Now, you should be looking at this, and whenever you hear about area and a triangle, the first thing that should pop into your mind is half base times height. So let's pretend that we actually have this as a question. Okay, there's a right angle triangle, that's 10 centimeters, that's 7 centimeters. The area of this is going to be half 10 times 7. So the area is going to be half of 70 even, which is going to be 35 centimeters squared. How lovely. Nice little foundation question there. Area of a triangle. Now, what's different then between the area of this triangle and the triangle that we've got here? Well, again, it's the fact that this doesn't have a right angle. In order to use half base times height to find area of a triangle, you need a perpendicular height, so you need a right angle somewhere. We don't have one here. Same problem that we had with the previous 2 questions. Now, like I said before, if ever you get a triangle that doesn't have a right angle anywhere, you want to go to your triangle section of the formula sheet, because down the bottom you'll see it says area of triangle. And again, they've mentioned A, B's and C's. Don't get bogged down in what A is, what B is, what C is. It doesn't matter. As long as you know that the 2 lengths you have are not opposite the angle that you're going to use. Let's see what that means. So, to find the area of this triangle, first of all, I'm going to copy the formula down from the formula book. Half AB. Oh, look, that's like the area of a triangle. Half base times height. But, just like with the cosine rule, you've got a bolt on. And in this case, it's sine C. Now, I could call that AB and angle C there. It doesn't matter which way round it is, as long as the 2 sides are making a sandwich of the angle. So let's dump some values in. Half of, let's call that A, it doesn't matter. And let's call that B. And then sine C, which is 35. So let's go to the calculator and type in half. I'm not going to put half, I'm going to put 0.5. It's just the kind of rebel that I am, because I know 0.5 is half. So I'm going to do half, open bracket, 7, 10, in brackets of course, because I'm substituting, sine 35, close that off, equals 20.0751. So that is 20.0751, ... They would tell you in the exam what degree of accuracy they wanted to, and therefore you would have to round it. But I haven't done that here because it's just an example, and that's going to be in centimetres squared. That's area of a triangle. Alright, so here we have a question which is asking us to calculate the area of triangle ABC, giving you an answer to 3 significant figures. So they've told us ABC is a triangle, AB is 8.7, angle ABC is 49, ACB is 64. And we've got to find the area. Now, as I should always do, it's an area of a triangle question. I can see there's no right angles. I'm going to look to my formula sheet. And the first thing I'm going to do is just make a note of the formula. Half AB sine C. So I'm just going to put here area equals half AB sine C. But I'm not going to get caught up in what's A, what's B, what's C, remember, as long as A and B are the sides that sandwich the angle I've got. So let's have a look. Hopefully it's very clear from this diagram that I don't even have 2 sides, let alone 2 sides sandwiching an angle. So I'm going to need to do a bit of work in before I can dump my numbers into that formula. Now I've got an angle there and a length there, so it would be really nice if I knew what this length is. I've got 2 angles. To find that, I'd need 2 angles, 2 lengths. Maybe I could use the sine rule, but in order to use that, I'd need the angle there. So in fact, this length is not something I'm going to be able to use. Instead, because I know this is a triangle and they add up to 180, I'm going to go with something that I'm pretty comfortable with, and I'm going to find what this angle is. So this angle here is always worth doing. Now, triangles always have 180 degrees in them. I need to subtract that 64. Then I need to subtract that 49. And that leaves me, so we're dealing with angle A here. That leaves me with angle A being equal to 67 degrees. So I'm going to add that in there, that's 67 degrees. So now I've got that angle, I've got this length. Maybe I could find this length and use that as my sandwich. So I'm going to find this length here, length AC. I've called it X. In fact, because it's opposite angle B, it may be more appropriate if I call it lowercase b, because the lowercase letters are always opposite the uppercase angles. So I'm going to need to use sine rule here in order to find out what b is equal to. So sine rule. And because it's the length I'm trying to find, I'm going to start off with the length. So b over sine of its opposite angle, which is 49, is equal to one of the other lengths. It's got to be that one, 8.7, over the sine of its opposite angle. So sine of 64. Now, I want b on its own, so I need to multiply that sine 49 away. So I'm going to be left with b equals sine 49, and that would be in a bracket. Then I'll open another bracket because I need to multiply it by the quotient of 8.7 over sine 64. When I put that into my calculator, and I'll do it for you so you can see, I'm going to do sine 49, close that bracket off, open bracket, quotient 8.7 over sine 64, close bracket, bring it to the outside of the quotient and close the other bracket off. So that equals the length of B, which is 7.3053 ... As always, I'm not rounding that off at the moment. I'm just going to keep it as it is and leave it on my display in case it's useful. So I'll write up here, length B I've just found to be 7.305. That's there. Now, because I know that length, let me highlight it in. I know this length, and I know this length, and I know the angle that they're sandwiching. I can use those values to dump into my area formula, which is here. So the area of this triangle is going to equal half of, I need to find, let me zoom out, I need to find the product, so times together, the two lengths either side of the angle I'm using. So I'm using that angle, so they are my A and B. So half of 7.305 ... because I'm just going to leave that on my display, multiplied by, so another bracket, 8.7 sine of C, and the C I'm using is there, which I just found to be 67 degrees. That would be in a bracket on the calculator. So there's my previous answer that I left on there. I need to now do half, so I'm not pressing delete, I'm just typing in 0.5. There's that rebellious nature of mine again. Instead of putting half in, I'm doing 0.5, open bracket, my answer from before, or you could type that in, that would be fine. Open bracket, 8.7 sine 67, close the bracket off, equals 29.2519. So that equals 29.2519 ... Let's check the accuracy. 3 significant figures. 1, 2, 3. Cut it off there. Pay respect to the fact that there was a 5 following, and therefore the 2 needs to round up. So that's 29.3, and it is an area I'm finding, so that'll be in centimetres squared. And that's the area of a triangle without a perpendicular height done. Here's a way simpler area of a non-right angle triangle question. Use the formula from the formula book. Have a go. Press pause. When you're ready for the answer, press play. Okay, like I said, this is a lot more straightforward. Either way, they're asking for the area of a non-right angle triangle. I'm going straight to my formula book and I am writing down that formula for the area of a triangle, which is half AB sine C. And in this case, I do have two lengths sandwiching an angle, so I don't need to calculate anything else. I can just dump my values in. So there, half of 6 and 7 sine 60. So we'll quickly put that in. Half of 6 and 7 in brackets sine 60. Close the sine bracket off, press equals 21 root 3 over 2, press SD. That gives me 18.1865 ... We wanted it to 3 significant figures. 1, 2, 3. Cut it off after the 1. Pay respect to the fact that the next number along is over 5. Therefore, we need to round it to 18.2. We're working in centimetres and it's area, so it's centimetres squared. What a beautiful question. Now, part B actually goes on to ask you to calculate the length of side AB. So if you look again at the question, they want you to find the length of side AB. So I'm going to call that X. I'll zoom in. Feel free to go ahead and use the cosine rule to find that length. Press pause. When you're ready for the answer, press play. Alright, as you can see, I've made the executive decision to fold that part away. So we're just left with part B. That's it's kind of freedom I have these days. It's quite high tech. Try not to be too blown away by it. Right, so we were asked to work out the length of AB, given the answer to 3 significant figures. I can see there's 3 lengths in play here and an angle that isn't a right angle. So straight away I'm thinking cosine rule. I'm going to my formula booklet and there's the cosine rule. First thing I'm going to do is copy that down. A squared equals B squared plus C squared minus 2bc cos A. And again, I don't care what A's are, B's are, or C's are, as long as the side I'm trying to find, I have the angle opposite it. And in this case, I'm trying to find that side, and I do have the angle opposite. So let's dump the numbers in. Instead of A squared, I'm actually trying to find x squared. So I'm going to say that x squared is equal to that squared plus that squared. 6 squared plus 7 squared minus 2 lots of 6 and 7 cos 60. And I should put that in a bracket because that's how it would be on a calculator. So I then go to the calculator and I type in, let me zoom out, so high tech. Oopsie daisy. Right. 6 squared plus 7 squared, take away 2, open bracket 6, 7 cos 60, close that off, equals 43. So, oops, x squared equals 43. I don't want x squared, I want x. So x is the root of 43. So there's 43 on my display. I'm pressing root, answer equals, root 43. Press the SD button. That's 6.557 ... They wanted it to 3 significant figures. There's 1, 2, 3. Cut off. Pay respect to the fact that that 7 is bigger than 5, and therefore I need to round it up to 6.56. It's a length that we've had to find, so we need to put centimeters there. That's the cosine rule. Right, this question is about the area of a triangle, but you're not being asked to find it, you've been given it. All right, so you're going to have to set something up here. I'm going to let you have a go at it. Press pause. When you're ready for the answer, press play. All right, so they've given you the fact that length AC is 8.4 meters, angle ACB is 40, and the area is 100 meters squared. They want you to work out the length of AB, given your answer correct 3 significant workers, showing all of your workings out. So let's label first of all the length of AB. They want this here. All right, now information they have given us is that the area of the triangle is 100 meters squared. I should be familiar by now that when there's an area of a non-right angle triangle, the best thing for me to do would be to look at the formula sheet and write down the formula for the area of a triangle. So that's what I'm going to do. Area equals half AB sine C. And I don't know what A is, B is, or C is, but what I do know is the angle that I use has to be sandwiched between the 2 lengths. So, because the side I'm trying to find is over here, this is not good to me at the moment with regards to finding that length. Unfortunately, because that's the only angle I have, and to use the area, they need to be sandwiched in between the 2 lengths. I'm going to need to use this to find this length here. And this is the length opposite angle A, so I'm calling it A. That doesn't necessarily need to correspond with the A's and B's that are in here. So what do I know about the area? Well, I know that the area is equal to 100. So 100 is equal to half of A, well, let's use A, times by 8.4 sine C, which is 40. Oh, so they've actually been quite nice here, and it does work out as A, B, and C. All right, what doesn't help me is the fact I've got this A here. And in fact, I don't want the A. I want a value for that A. So what I'm going to do is I'm going to just pretend that I don't have that A for now. Because all this means is half times A times 8.4 times sine 40. So if I don't times the A in, what I'll end up with is 100 equals on my calculator, half, in fact I'll put 0.5 as to not confuse you, half, I'm leaving the a out, I'm going straight to 8.4 sine 40, closing that off, equals, and that's that answer there, okay? But remember, that is everything apart from the a. So that's 2.6997 ... times by whatever a is. So at this point, hopefully you can see that I'm going to need to get a on its own. Therefore, I need to divide this monstrosity away. And I'll need to do that on both sides. Now, I haven't pressed clear on my calculator display. I never do. Because I know that in order to get a on its own, I'm going to need to do 100. So I'm not pressing clear, I'm just typing in 100 divided by the answer equals. That gives me 37.041 ... So that's that length there. I'm going to write it in up here, 37.041 ... So I'm not going to do any rounding yet, and I'm going to keep that on my display just in case I can use it later. Well, that's all well and good. I found what a is, but I didn't want a. I wanted this length. But now hopefully you can see I've got this angle, which is sandwiched. Let me get my highlighter. I've got this angle, which is sandwiched between that length and that length, both of which I know. So to find that angle, I can use the cosine rule. 3 sides in use, plus the angle sandwiched between the two known sides. So to find AB, I'm going to use the cosine rule. And I'm always going to start by writing down what the cosine rule says on the formula sheet. A squared equals b squared plus c squared minus 2bc cos of a. Alright, let's dump our numbers in. Instead of a squared, I've called it x squared. So x squared equals, now I don't care what's b, I don't care what's c, all that matters is it's these two sides. So I'll go for the 8.4 first. 8.4 squared plus 37.041 ... squared minus 2 8.4 37.041 cos an angle A, which is 40. Now that's really messy, and in fact it was unnecessary for me to keep those as they are. So I'm going to go ahead, before I type this in the calculator, and just call it 37.041. Okay, so I'm not going to worry about pressing answer on this. Alright, so now I'm going to type this long sum in. So I've got 8.4 squared plus 37.041 squared minus 2 open bracket 8.4 close bracket open bracket 37.041 close bracket cos 40 close that bracket off equals 965.89. So that seems awfully large, but remember it's x squared. So x squared equals 965.8948 ... But I don't want squared, I just want x. So my answer's on there. I'm going to press root answer equals, much nicer, x equals 31.0788 ... What do they want it rounded to? 3 significant figures. 1, 2, 3. Cut off. Pay respect to the fact that that 7 is there and it's larger than 5. That means I round my answer up to 31.1 and the question's in meters. So that's what length AB is equal to. You'd be really unfortunate if you got that question in an exam, although in the end it wasn't so bad.